Okay, 5 boys, 5 girls have to be seated. How many ways if there's no restrictions? Okay, so I have to be putting these people, let's say I'm just lining them up for a photo kind of idea. I'm putting them in seats to take a photo of them. Okay, so 5 boys, 5 girls, so 10 people. So if there's no restrictions, how many options do I have to put somebody in my first chair? 10. Once you put somebody in that chair, how many options would you have to put people in the second chair? 9, 8, 7, 6, 5, 4, 3, 2, 1. What kind of math do you do to those numbers? Add, multiply? Which one? Multiplying, right? Okay. I could type all that out. What's a faster way to type that? Ten factorial, right? What is the definition of a factorial? When you start at a number and times all the way down to 1. So 10 factorial. Okay, this time we have to alternate between boys and girls. Okay, so 2 boys can't sit beside each other, 2 girls can't sit beside each other kind of idea. Okay, so here we go. How many options for the first chair do I have for people? 10. I can put anybody there. Okay. Now, pretend you put a, what do we want to say we put here? Pretend we've put a boy there. How many options do I have in here? Now I only have 5 options. Why? Because if I did put a boy, now I have to put a girl. So now I'm back to being a boy option. So now how many boys do I have left? 4 boys. Now a girl. Back to a boy, girl, boy, girl, boy, girl. Okay? Does that make sense why I started with 10 though? Because how could you have started? You could have started with a boy or started with a girl. Okay? Another way to think about this is 5 factorials for the girls times 5 factorials for the boys times 2 because you had 2 options to start. That's another way to think about it. If that confuses you, don't think it like that, but that is why there's a 10 in there, because you had 2 options to start, so you're timesing one of the 5s by a 2. Good? Okay, so just paying attention also to this starting one where you had just 2 options to starting. Okay, 10 people. This time, Andrew and Zach are best buddies and they have to sit beside each other. Okay, so what I'm going to do is I'm going to chunk them together like that. Okay, so if we go back up to the top, this one we had 10 people moving around. Okay, does that make sense? That's what we were doing. We had 10 people, we can move them around anywhere. So if Andrew and Zach have to sit beside each other, it's almost like we're putting them as just one person. Because when we move them, if we want to move them to the middle, they have to move together to the middle. Okay, so it's treating them like one person right now. So how many things am I moving around now? So that before here, we were moving around 10 things separately. So how many things am I moving around? Now I'm just moving around 9 things because we're treating them together like one. But, hey, what could Andrew and Zach do? So if I put Andrew and Zach like that, I could also consider putting Zach and Andrew flip-flopping as well, right? So how many objects are you moving around times what can you do within that little grouping that you glued together? Okay, so this is considering that every time you place Andrew and Zach somewhere else, so if I put them on the end, okay, I could also do Andrew, Zach, or Zach, Andrew. So that's why I'm doing that part. Okay, now we got 3 buddies that want to sit together. Andrew, Zach, and Toby all want to sit together. So when I place the 3 of them somewhere different in the moving positions, they have to be moving together. So I'm treating them like one object now. So how many objects am I moving around? So 1, 2, 3, 4, 5, 6, 7 individuals plus 1 group makes 8 objects that you can move around. Okay, because we can do this with books or whatever else too. Times, well, what could Andrew, Zach, and Toby do just in their own little space? They can flip-flop with each other. Even though they're beside each other, they can still move around within. Okay, so that's the strategy. How many objects are you moving around once you've chunked an object together, but then you have to multiply what's within the object that's grouped. Boys and girls are going to sit in couples this time. Okay, so when these people move, they have to move together because they want to stick together. So we're gluing couples together like that. Same strategy. How many objects get moved around now once we've glued? Now I'm only moving 5 objects around. 5 couples get moved around. Okay? But what's happening within? So this couple could move around, flip-flopping. Oh, but so could this couple, and this couple, and this couple, and this couple. So I'm not going to write this, because what else could I write instead of doing this? What's a different way to write that? Exponents. What is 2 factorial as a number? 2, right? 2 times 1. 5 factorial times 2 to the 5th. I don't even know if it would let me do 2 factorial to the 5th. Does it let me? Yeah, it does. Okay, this last one. Ooh, if we don't remember the strategy on this one, you're kind of hooped. Okay, to figure out where they don't sit together, trying to just get that is almost impossible because it's a crazy amount. So here's what we're going to do. We're going to talk about scenarios. So there's a bunch of arrangements. What is the all arrangements that you could ever do? We have it on our page. Where did we do all arrangements ever? Which one shows me what could be all the arrangements? Part A, right? So out of all the arrangements, would you understand the scenarios are that they sit together, or the flip of them sitting together is not together? All the times they're sitting together and all the times they're not sitting together, what do you think these two numbers would do together? They would add up to complete the all options. Does that make sense? There's all the scenarios. Within the scenarios, there's going to be scenarios where they're sitting together or not sitting together. Okay, so here's what I'm going to do. I'm going to take all minus the opposite event. So if I do this, subtract this, I can figure that one out. Does that make sense? Because do we know how to do when they sit together? Yeah, now we know how to do that one. So out of all the arrangements, there's going to be arrangements where they're either sitting together or not sitting together. So to get that, we're going to subtract those numbers. Okay, so what was all 10 factorial? Was any arrangement that there ever could be when they sat together. Okay, so we've done that example. So that was in question C. That's where I'm getting this from. We already did that work, right? Can you do that A on our page? All was the A, and then when they sat inside each other was C. So you can subtract those numbers. Okay, so if you kind of blank on that idea, I don't know how to figure just this out. If I was to get this, it'd be very impossible. Okay, so all minus the opposite thing will leave us with that scenario. Okay. Okay, a school has 8 doors. How many ways could you go in the building and out of the building? So here's what we're doing. We're going to go in the building and then we're going to go out of the building. How many options do I have for going in the building? 8. How many options do I have when I go out of the building? 8. What kind of math do I connect those numbers with? Times. Because am I doing this and this? Question B, how many ways can you go in one door, but when you go out, you have to go out a different door? So what's different in this question? 8 ways to go in, but now there's 7 ways that you can go out. How many different PIN numbers are there for your banking card? What do you have in your banking card? How many digits? It's a 4-digit PIN, right? How many options for this digit do you have? How many numbers can you pick from? It's 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's what I did. There was 10 options that I could put there. How many options do you have to pick from when you do your second number in your PIN? You still have 10 because PINs let you repeat. And another 10 options and another 10 options. And what do you connect that with? Your PIN is you're doing this and you're doing this. So when my husband and I were dating and we'd gone to a bank and then we were at a drive-through, so I passed my card over to him. I'm like, just get me some money. And then I gave him my PIN number and he looked at me and I'm like, why are you looking at me? He's like, you have the same PIN number as me. I said, what? 10,000 options and we had the same one. And mine was completely random because when I traveled in Australia, the friend I was traveling with gave me an Australian card and he's like, here's your PIN number. And so it was like completely random. And we ended up with the same one. So that's why we're married, because the math told us the odds were 1 in 10,000 and we should be together. How many different 3-digit even numbers less than 400 can you make? Okay, so let's talk. When I'm even, it only means I have to end. So I could be a 2, a 4, or a 6 option for options there. And if I'm less than 400, the options are 100, 200, or 300 in that spot. Okay, so we're going to do some scenarios here. I'm going to do the 3 different scenarios of what if I made a 100 number, a 200 number, or a 300 number. Those are different scenarios. Okay? Does that make sense? They're different. Okay, so if I wanted to start with 100 something, how many options do I have to start with a 1? 1. Okay? And I have to be even. Okay, so how many options do I have for even? 3. No, because it said using these digits. You know what? I should write, I'm going to write no repetition. I should have wrote that. Something, you'd have to either know because it will make a different answer, sorry. Okay, so again, you're only allowed to use these values. So how many options do I have for my middle number? So that was 7 options to begin with. And I've already used something in the front and I've already used something in the back. So I'm left with 5, right? So there's 15 ways you could make a 100 even number. Okay, here we go. What if I started this as a 200? How many options do I have to start something with a 2? There's only one way you can start 200. How many options do I have for an even value here? A little tricky to think about. I only have 2 options. Why do I only have 2 options in this even spot? Because you already picked the 2 somewhere else. So you can't use it again. Do you see it? Can't use it now. Okay, and then I'm left with 5 more digits. So there's 10 ways to make a 200 even number. How many ways can you make a 300 even number? So if it starts with 300, there's one option to start with a 3, which leaves me 3 options for an even value and 5 options. Okay, so do you see why this is a 2 instead of a 3? Because you've used the 2, so now that's out of the options. So what do you do with scenarios when you have this scenario or another scenario? You need to add. Okay, so these things were happening in one scenario, so that's an and. This and this are happening, but now different scenarios. Okay, we have 5 red, 4 black, 2 white. So that is 11 cars. Okay, ready? I need to put a red car on each end, and I need to put a red car in the middle. Okay, so here we go. I need to put a red car at the start. How many options would I have to pick from? 5. And I need to put another red car in the middle, so how many options now? 4. And then over here, I would have 3 red cars left to pick from. Now, this can be just any car, right? There's no criteria out of anything else. So I put 3 cars into their places, so how many cars do I just have left? I had 11 cars, so now I have 8 options, 7, 6, 5, 4, 3, 2, 1. So those were mandatory, and then just all the rest of the cars can just go anywhere. What would be a faster way to type this? I see an 8 factorial times 5, 4, 3. Why can't I do 5 factorial? Why would 5 factorial be wrong? Because you're not going down to 1. You're not going 5, 4, 3, 2, 1. Okay, that's not the same. Okay, does that make sense why it's not a factorial there? Okay, this time you have to group your cars together. They have to sit in their colors. So all the reds need to be glued together when they move. All the blacks and all the whites. So I could put like red, black, white. I could do black, red, white. I could go white, black, red, right? I can move them around like that. So how many objects am I moving around? I'm only moving 3 things around. I'm moving red, black, white. I'm moving that around. But what could the red cars do? They could move around inside themselves, and then the blacks, and then the whites. So how many objects, and then what are they doing within? So we did this strategy before, right? When Andrew and Zach wanted to sit beside each other, how many objects are you moving, and what's happening within their little grouping?